Hi, welcome to Module 12, Menu-Driven Program Design. I'm your professor, Dr. English Dowdell. Now, up to this point in the course, you've learned how to use sequence, selection, and repetition structures, and how to break programs into modules. Now we're going to pull all of those ideas together to design a menu-driven program. This is one of the most common structures you're going to see in modern software and even in simple console-based applications. Now, think about the programs or apps that you probably use every day. So, like maybe your phone settings, ATM machine, or even restaurant kiosks. What do they all have in common? They give you choices, menus that let you select like what it is that you want to do next. That's exactly what we're going to be designing this week. So by the end of this module, you should be able to explain what menu-driven structures are and why they're used, create pseudocode for menu selection logic, and then organize programs using menus and submenus. So a menu-driven program is a program that displays a list of options to the user and then performs an action based on whatever that user's selection was. So instead of typing in a command, the user simply chooses from like a set of predefined options. So for example, view balance, deposit funds, withdraw funds, exit. Now, this kind of design makes programs more user-friendly, more organized, and easy to navigate. Now, each menu option usually corresponds to a module or a function that performs a specific task. So the program as a whole becomes modular. It becomes organized and easy to maintain. So why do we use menus? So menus make software more interactive and logical. They allow the user to control what happens next rather than having the program run in a fixed order. From a programming logic perspective, menus will use structures like if, else, if, or case statements to handle choices. They'll often use loops to keep the menu running until, say, the user decides to exit, and they call modules to perform specific tasks depending on the user's input. Okay, so let's look at a simple pseudocode example that illustrates the structure of a menu-driven program. So we've got the main module. We're calling the display menu, get user selection. If selection is 1, call view balance. Else, if selection is 2, call deposit funds. Else, if selection is 3, call withdraw funds. Else, display invalid option. So what's going on here is the program is going to display a menu, okay? And the user is going to enter a choice, 1, 2, or 3. Now the program branches depending on, say, the user's choice using the if-else, if statements. And then each option is, say, connected to its own module. Okay, so let's go through each piece step by step. Okay, so display menu module. This is where we show the user what they can choose from. Now it's important that the options are clear and numbered for easy input. So 1 is view balance, choice 2 is deposit funds, choice 3 is withdraw funds. This is what we're displaying to them, okay? The next one is this view balance module. Now this is a simple output module. No input, no calculations, just a display of what their balance is. So if they select 1, we're going to be calling this module. Okay, the next one, deposit funds module. Now here the user is prompted for an input, and then we provide feedback confirming the action. So we're prompted for them to enter the amount to deposit, then we get that amount, and then we display the amount deposited. The next one is the module for withdraw funds. Now, this is where we would, you know, it's more of a concept, same concept as this deposit, okay? But we ask for input and then we display a message. And then what I don't have on here would be the invalid option. And of course, that is going to catch any number or any characters that don't match the available options. So if they pick something other than 1, 2, or 3, we're going to display that it's an invalid option. Now, it's a critical part of error handling for user input. So we always want to make sure that we do include that within our program. Now, this week's first assignment is to build a flowchart based on the pseudocode. Okay, now the flowchart should visually represent the logic flow from start to finish, from displaying the menu to executing each option. So let's break it down of how we would build it step by step. So we're going to have that start symbol. Okay, remember this is going to be your oval labeled start. Okay, then we have the display menu. So we use a rectangle and we have display menu options, and then we list all of the different options. Then we have the get user input. So this is also another rectangle with the get user selection. So we're getting whatever the selection is that they've chosen from the menu. Then we've got our first decision symbol. Okay, remember decision symbols, we use diamonds. Okay, and the first one is labeled, is the selection equal to 1? So if it's yes, then we're going to go ahead and we're going to call the view balance module. Okay, but if it's no, then we're going to go on to selection number 2. Okay, if selection number 2 is correct, then we're going to call the deposit funds. Okay, and then we're going to do what the deposit fund module does. If no, then we're going to go on and ask, is it selection 3? And if it's yes, then we're going to go ahead and call the withdrawal funds, and then we're going to do whatever the withdrawal funds module has us do. But if it's no, that means that they entered something that wasn't the number 1, 2, or 3, and in that case, we're going to display invalid. So this is where, again, they don't match, okay? And then we are going to have an end symbol. This is going to be our oval to show that the program is finished after displaying results. So after displaying invalid, then we end it. After displaying the withdrawal, with the withdrawal funds, then we end it. Same here for the deposit funds. We end it after we display deposited. And then for the view balance, once we display the balance, then we end it. Okay, so again, this is just a little review of the symbols that you're going to be using with your flow chart. So an oval would be more of your start and your end point. Okay, rectangles are going to represent the different processes. So this is going to be your input, your output, and any action that's taken. Your diamonds, remember, these are your decisions. Okay, this is the yes or the no, or the true or false. And then, of course, the arrow is going to actually show the flow of the control. This is what's going to connect all of the steps. And remember, with the diamond, this is more or less the if else. Okay, this is where we had like the if else. Now, the different tools that you can use, you can hand draw the flow chart, and then upload the picture, or you can use Draw.io, you can use Google Slides, you can use PowerPoint to design it, you can use Canva, or you can use Figma. But be sure to include your name and label it Module 12 flowchart, with whatever you submit as far as your image. So for this week, your first assignment is going to be to build a simple menu-driven flowchart. Okay, so you're going to create a flowchart based on some provided pseudocode that I give you. So your requirements for this is going to be, you're going to start with a main menu. You're going to show the menu display, the user input, and the different branches, like I just demonstrated. You're going to include an invalid option path, okay, if they don't choose a menu option, okay. I want you to use the standard symbols that I just showed you, okay, and again, it can be hand-drawn or you can use, a tool or something to do this. Now, for another assignment is going to be to actually continue working on your project milestone. Okay, and with that, This is flowcharts and pseudocode. So you're going to be creating flowcharts and pseudocodes for your system modules. Okay, remember your system modules are register, maybe you use cancel as a system module. You may have used view schedule as a system module. So you're going to create a flow chart for that. You're going to write the draft pseudocode for each module, and then you're going to apply sequence and selection and repetition principles, very similar to what we've already done in this video. So what you're going to submit is you're going to submit that flow chart, okay, for each of the major modules. That include each of the major modules, and then you're going to submit the pseudocode document. Now, if you have any questions about any specific things as far as what's due for the milestone, what the expectations are, please reach out to me. But in the course room, I think I go into a little bit more detail as far as what milestone 3 is going to entail. But to help you out, I've kind of provided this. So, for your course project, I want you to think of the menu-driven structure as the main navigation, okay, of your system. So, for example, if you've got like the community center registration system, so your main menu might look something like this. Number one may be register for a class. Number two may be cancel a registration. Number three may be view schedule. And of course, number four may be exit. So each option would connect to, say, a separate module, just the way we saw in the sample pseudocode earlier. The register module might ask for user information and class ID. The cancel module might ask for a registration ID in order to cancel it. The view schedule module might display all current classes. Now, each of these modules should have a flow chart showing the logic flow. Okay, so each module, I want you to have a separate flow chart. Okay, and then you should have pseudocode that's describing the logic step by step. Again, if you have any questions, please reach out. Now, here's some helpful hints when designing your menu-driven logic. One is to keep your menu clear and concise. So you want to use short labels like view balance instead of long phrases. Second one is to plan the flow before you start coding. You want to start with a flow chart in order to map decisions and actions. The third one is to use modular thinking. So each option should call its own module. This keeps your design organized. You also should add input validation. So always include a step for invalid input so that the program doesn't crash or stop unexpectedly. And then loop if necessary. So in many menu-driven programs, we keep showing the menu until the user chooses to exit. Now we'll focus more on looping menus a little later, but it's good to start thinking about that now. Now let's summarize what we've covered today. So menu-driven programs, they use menus to guide users' choices. They use selection logic, like if, else, or case logic, to branch into, say, different modules. Flowcharts usually or visually represent these structures using more standard symbols like the ones that I've showed you. Now each menu option is going to connect to its own module, and this makes the program modular and easy to maintain. And then again, your assignment this week gives you practice in both flowcharting and pseudocode for menu systems. Now that's it for this module's lecture on menu-driven program design. So take the time to review the example pseudocode and make sure you understand how each user choice connects to a separate module. Then use that structure as inspiration when you design your own flowcharts and pseudocode for the project milestone. Now, if you need help, review the lecture again or check chapter 11 in your textbook for more menu examples. You can also post in the Q&A section or discussion board, if you run into any trouble, building your flowchart, or like I said, just reach out to me. So good luck, and I can't wait to see, how you bring your program logic to life through menus and modules. Have a good week.